before where we were comparing planets. So let's just organise our data a little bit better and revise some of our skills with resizing. So we have our order here column, which doesn't need to be quite as wide. So we're going to hover over and drag back to make it the right width. With our columns B, C, D, E, F, G, and H, we can double click to make it the size we want. Now on this spreadsheet, we're going to have multiple tabs along the bottom. Currently we've only had one tab, now we're going to have multiple. So we need to give them a bit more meaningful names than we currently have. So this one is called Sheet 1. We're going to double click on that and we're going to call it Planets. Then we're going to add a new sheet. So using this plus button here, so adding a new tab or sheet, and we're going to call this Birthdays. I'm going to give it a title of Birthdays. We're going to make it the right size. And we're going to put in cell A3, enter your age. And then in cell B1 for the moment, B3, sorry, we're going to put 1. We're going to make that into a table, so add some borders. Add a bit of bold there. And then underneath, we are going to do the different planets. And we're going to work out how old you would be on each of the planets. So rather than typing them all out from here, what we're going to do is we're going to use that data and we're going to link it through. So to do that, what we're going to do is we're going to click in cell A5. We're going to press the equals button on the keyboard. And then we're going to take our mouse down to the Planets tab at the bottom. And we're going to click in cell B3 where it says Planet. And we're going to press Enter. Now if we click into there, you will see in the formulas bar we have a formula that says equal planets exclamation mark B3, and that means go to the Planets tab, go to cell B3 and get whatever's there. Okay, it doesn't bring the formatting through, it will just bring the contents. Now we could do that for every single planet. However, we can use the power of autofill because the planets are already underneath in the right order. What we can do is we can just pull down on it, okay, until we get all of our planets through. If you go too far, don't worry, because it will just bring a blank line through. So here are all our planets, and what we will need is we need their orbit period, their year length in Earth years. So same as before, we're going to go to cell B5, press equals, take our mouse down to the planets, and we're going to find their cell G3 orbit period, and we're going to press enter, and then we can drag down with the corner, autofill down to bring all the data through. Now what we need to do is add a third column, and we'll say your age on planet, which we're going to calculate in a moment. But before we do that, let's just make our table look like a table. Let's make our titles look like titles. You can add a bit of colour, a bit of filling if you want. Okay, resize those columns. And then we're going to do the maths on how to do this. So what we need to do is we need to say our age currently on Earth divided by how long a year is in Earth years on that planet. So to prove that this is the case, if we go onto here, we've got your age on planet, we're on Earth. If we do an equal sign, let's click on our age, do the divide sign, which is slash, and then we're going to divide it by the orbit period of the Earth number of years, and press enter. And we'll say no to the autofill at the moment, and you will notice that it is slightly less than 1. This is because this number here is actually a lot more complicated. If we were to increase the number of decimal places, you will see that it is a lot longer than that. Okay, but we're going to reduce that back down to 3 decimal places. This one is our age on our planet, so it's just under a year. Now, you might think that we could autofill and it would automatically work it out for Mars and so on, but it won't quite. So what we're going to do is we're going to delete that one out, and we're going to set up a formula at the top here to work it out. But we're going to use a special type of formula using a dollar symbol to keep this cell always used. So we're going to do an equal sign. We're going to click on that cell. We're going to do a / for divide, and we're going to click on Mercury's orbit period. So equals B3 / B6. I'm going to press enter. We're going to say no to the autofill because you can already see that there's a problem here. And what we're going to do is click back on our cell here in C6, and we are going to amend it slightly. What we're going to do is we are going to fix the formula so that it always uses cell B3, because if I autofill it at the moment, what will happen is it will start using B4, which has got nothing in, then B5, B6, B7, so it won't work. So what we need to do is we need to make sure it always uses B3. Now, we could do it by doing manually each one, but that would take too long. Okay, we want to use our autofill, but we need to tell it to always stay with B3. So what we're going to do is we're going to click in the formulas bar up here, and we're going to click between the letters B and the number 3. And we're going to type a dollar symbol, as in American dollars. What that means is, it means always stay on row 3. Don't need to show it to the B6 because the B6 is the thing that we want to change each time for the different planets. So if we press enter on that, click back on the cell, and now use our autofill down, and you will notice that it has calculated all of them. However, it's calculated in very long numbers with lots of decimal places, and we want to reduce the decimal places here by clicking to decrease the decimal places. Let's just decrease it to 1 decimal place. Our age on the planet of Earth, if we're 1 year old, is 1 year. If we were in Venus, we would already have been around the sun once, and we'd be 1.6 years old in Venus years. And in Mercury, we'd have been around the sun 4 times already, so we'd be 4.2 years old. However, at Saturn, Uranus and Neptune, we wouldn't yet have even got around. Take a moment and just change your age to your actual age. For instance, if you're 10, and you will notice that it's recalculated all of the ages. Different planets have different gravity amounts. On Earth, we can jump up and down, and gravity brings us back. Different planets have different amounts of gravity. For instance, Mercury has 3.7, and we have 9.81 meters per second squared. If we then add a new tab after birthdays, let's work out how high we could jump on each planet. So let's rename our tab by double clicking and going to jump. And then what we're going to do is we're going to put jump height, and remembering our units in meters. Let's say you could jump half a metre for the moment. Okay, so 0.5. And then, just like before, what we're going to do is we're going to get the planet list, and we're going to get the surface gravity as well. So we're going to press the equal symbol. We're going to head back to planets. We're going to click on planets in B3 and press enter. We're going to drag down, and then we're going to go into cell B5. We're going to press equals. We're going to head over to planets. We're going to grab the surface gravity in E3, and we're going to drag it down. So now we've got a table with 2 columns, but what we're going to need is we're going to need 4 columns. So let's add some borders. Let's add our missing titles. What we're going to have is conversion factor, and then the jump height on planet in meters. And let's just rearrange our column slightly so that we can see all of the data and all of the titles. Let's give those titles some bold. Let's give this a bold as well. Okay, now we're ready to do some calculations. So, conversion factor is a column where we are going to convert the surface gravity with our jump height. So, for instance, if we are on Earth, we will have a conversion factor of 1 because we don't need to convert our gravity on Earth. We've already got it calculated, so we only need a conversion factor of 1. So to do that maths, what we need to do is we need to use our formulas again with our dollar symbol. So we're going to start with the Earth one in cell C8. We're going to do equals. We're going to click on B8, which is the gravity on Earth, and we're going to divide it again by the gravity on Earth, so it should be 1. However, we're going to click back into that formula and we are going to put a dollar symbol between the B and the 8 on the first half of the equation. It is suggesting to autofill, which we can do, but I'm going to reject the suggestion to show you how you can autofill in both directions. So our formula is now equals B$8/B8. If we autofill down, we've got these values ending in 0.879. We can also fill up as well by clicking on the cell and dragging up in the same direction. We want to simplify these to 2 decimal places, so highlight them and reduce the number of decimal places to about 2. And now we're going to work out our jump height on the planet in metres. Now, our jump height on Earth, if we're saying that we can jump 0.5 metres on Earth, well, the answer is also going to be 0.5 here, but we want the spreadsheet to calculate it for us. So what we're going to do is we're going to say equals, we're going to click on B3, which is our jump height, and we are going to multiply it by our conversion factor. Now, again, if we autofill down, our formula would be wrong because we always need to use B3, our jump height, in our formula. So we're going to add a dollar symbol between the B and the 3 to make sure that it always stays B3. And then we are going to autofill our formula down. And you can check here with Earth, 0.5, 0.5, we have got the right maths. Reduce those to 2 decimal places again. And you will see that on Mercury, if you can jump half a metre on Earth, you would actually jump 1.33 metres. Experiment by changing your jump height. For instance, if you could only jump 20 centimetres, what about if you could jump 3 metres? See if you can find out how high you actually can jump and see what the highest jump height is in the Guinness Book of Records or something like that. See if you can calculate how far they'd be able to jump on different planets. And that's all you need to do, other than to add some formatting, add some images, and see what else you can find out how to calculate.